Let's continue on with the video homework guide for limits. We're now moving on to page 60, and on page 60 we will start with example number 9. And we have more limit questions where x is going to infinity. So if x is going to infinity, these are probably looking like horizontal asymptote questions graphically. Now, for the questions on page 60, example number 9, the theme here is now we have a square root. It's somewhere in the problem. The square root might be on the denominator. It might be on the numerator. Regardless of where the square root is in the problem, we need to apply some different techniques and strategies to break it down. Before I actually start breaking down this problem, there's a few ideas that I would like to go over with you before we start this problem. And that is, if I have the square root of an expression, and if I divide that by the square root of another expression, there's a property that you should have covered in your Math 9 class, and that is the square root of a divided by the square root of b is the same thing as the square root of a divided by b. So this is one of the ideas that we need to know for solving a problem like the problems on page 60. Another idea that you need to know, so this is from grade 9, another idea that you need to know from grade 11 is the expression of the square root of x squared. So in grade 11 and even in our calculus class, it was discussed that this expression is the same thing as the absolute value of x, and the absolute value of x has two parts. It has x when, and in calculus it's just x when x goes to infinity, or it could be negative x when x is going to negative infinity. So later on in this problem, if you ever see the absolute value of x, you need to get rid of those absolute value signs by replacing the absolute value of x with just a single x if we're going to positive infinity, or a negative x if we're going to negative infinity. Now for our very first problem, we're going to positive infinity, so we're going to be dealing with just a single x later on in the problem. Okay, so I'm going to solve this problem using some longer methods, and then I'll show you another quicker method to solve the problem, and hopefully we can start getting through these problems quickly. Alright, let's erase all this, and then let's go ahead and start solving these problems. Okay, so the very first thing I would do in a question like this is I would find the highest power in the square root. So this is like language that I'm just making up. And what I see right here is this part right here, that's the highest power in the square root. And the way that I'm going to write that is as the square root of x squared. Okay? Alright, then what I'm going to do next is I'm going to rewrite this limit statement, and I'm going to divide every single term by the highest power in the square root, which is root x squared. So I'm going to rewrite my limit statement. I'm going to rewrite the numerator, and I'm also going to rewrite the denominator. Alright, so my next step is I'm going to take this highest power in the square root, and I'm going to divide every single term by that expression. Okay, so if I do that, let's move on to the next step. As I was saying, if you ever see this expression right here, the square root of x squared, that's the same thing as the absolute value of x. So this is 4x plus 1. So I could write the absolute value of x over here on these expressions here. But then remember, this problem that we're solving, x is approaching infinity. So if it approaches infinity, the absolute value just becomes x. So I'm just going to get rid of the absolute value signs now. Just 1 second here. Just gotta change colors here. Erase that, erase that, erase that. So the numerator just simplifies to 4x over x plus 1 over x. Now for the denominator, you have to recall this idea from Math 9 here. So if I simplify the denominator, it's going to look like this. X squared over x squared minus 2x over x squared. Actually, maybe I'll erase these guys and put them in blue so that it's a little bit clear on what's happening here. So this is x squared and that's x squared. Okay, so now that we've done that part of the problem, we need to simplify this question so that we can break it down and eventually substitute our x going to infinity expression there. All right, so let's go ahead and simplify this now. So I'm going to rewrite this as the limit. This is the limit as x goes to infinity. Now this expression is going to be 4 plus this expression is going to be 1 over x divided by this expression right here is going to be 1 minus, and this expression right here is going to be 2 over x. Now we can go ahead and plug in this infinity for all the x's. And when we do that, we know that these terms just go to 0. So now you're left with 4 on the numerator, and you're left with the square root of 1 on the denominator, and the final answer is 4. So a little bit of algebra there, and it works out to be 4 as our final answer. Okay, let's just go back here, and I will erase all this, and I will show you another method to solve this problem here. Okay, so let's move on to something we call method number 2. Now, just for a heads up, method number 2 does not work all the time. And there are some problems I'll show you where it doesn't work, but luckily method number 2 does work for question number 1 here. Now, what we do here is I have a 4x and a 1. Which has the higher degree, or which has more x's? Well, the 4x term has more x's. So what we're going to do is the constant here, this is a constant. The constant is just going to go to 0, so I can just get rid of that. And if I look at the denominator here, which has a higher power of x? Is it x squared or 2x? Well, it's x squared. So since I'm comparing things inside the square root, this x squared is definitely has a higher power than the 2x, so the 2x, you can just set that equal to 0. So now you can simplify your problem into x goes to infinity of 4x divided by the square root of x squared. Now remember, this term right here, if you go back to your pre-calc 11 definitions, that's the absolute value of x. And since we're going to positive infinity, this absolute value sign just changes to a single x. And then those x's can cancel off and you get 4 as the final answer. So method number 2 works really, really well when you can compare the powers of x's on the numerator and the denominator. Okay, so sometimes we can use method number 2 and sometimes we can't, depending on how the problem's set up, but so far we can use it for these kind of problems. Okay, let's move on to question number 2 now. Alright, so for question number 2, x is going to infinity, and I have a square root in my problem. So the method that I will use right now is I will find the highest power in the square root, and that's going to be x squared with the root sign on it. And once again, this is my own kind of language that I'm using. It just kind of helps me kind of remember the key steps that I need to solve this problem. Okay, so I'm going to rewrite the problem as x plus 3, leave a little space, underline the square root of x squared plus 1 plus 2. Now I'm going to divide every single term by the highest power in the square root, which is root x squared, root x squared, root x squared, and root x squared. Alright, so although this expression looks very ugly, it's still mathematically the same thing as the original problem. All right, let me just go back here and just get rid of some of these signs here. Okay, so what we need to do now is we need to go ahead and simplify these limit statements. So this is the limit as x goes to infinity. Now this is going to be x plus 3. Now this part here in yellow, remember that's the same thing as the absolute value of x. But then the problem is going to positive infinity, so I can just really get rid of the absolute value of x and just write a single x, because the goal is we always need to get rid of the absolute value signs. and replace them with x or negative x. And since we're going to positive infinity, it's just going to be a single x. Now, in order to simplify this, like a radical divided by a radical, I can write everything underneath one big radical sign. This will be plus 1 over x squared. Continue on, plus 2 over, now once again, this symbol right here, the square root of x squared is really the absolute value of x, and the absolute value of x will be x in this case. Alright, so there we are. What we can do now is we can simplify this. So x over x, that's simply going to be 1, so I'm going to erase that and put a 1 here. Now let's go ahead and plug in the infinities for all the x's. And this expression right here that I'm highlighting in blue, x squared over x squared, that's also going to be just 1, right? And if you think about this logically, these will go 0, those will go 0, that will go to 0, and now you're left with 1 divided by the square root of 1, and 1 over 1 is just 1. Okay, let's go back to the beginning here, and let me also show you method number 2, because method number 2 works well with this problem as well. Okay, so just give me a second here to erase all this. So let's check out method number 2 here. Alright, so for method number 2, I noticed that there's some constants here and here, and if you do enough of these problems, you know the constants are just gonna go to 0. Because a lot of the constants, you know, what happens in these kind of infinity problems is that the constants are always going to be divided by a very big number, so they will automatically go to 0. And then ask yourself, on the denominator, what has the higher power of x? Is it x squared or is it 1? Well, clearly it's x squared. So if you rewrite your limit problem, it's the limit as x goes to infinity. The only thing that's surviving on the numerator is just x, and on the denominator we have just x squared because all these terms are now going to 0. Alright, so if we go ahead and just continue to simplify this, I mean, that's going to be absolute value of x. And in this case, since we're going to positive infinity, it's really just x. And x over x is just 1. So that's the same answer as we had before. Okay, now let's go on to question number 4. And for question number 4, this is one of the first questions where we can't use the quicker method number 2. And that's because we have an extra x term here. So if I look at the denominator in total, I can't compare like the x's, right? Because the problem is these two guys are in the square root, and this is outside the square root. So I can't use method number 2 here because I can't compare the powers in barely, because x squared is in the square root and that 2x is not in the square root. So I can't do a fair comparison there. Anyway, so for this problem we would probably stick with method number 1, and let's go ahead and find the highest power in the square root, and that's going to be x squared. So I'm going to write that as x squared in the square root. And once again, this is just my own fancy language that I use to kind of help me identify a key component here. Notice in this problem we're going to a negative infinity. So as we're doing this problem, we know we're going to see the absolute value of x, and in this question we should replace absolute value of x with negative x because of that, because it's going to negative infinity here. Okay, so keep that in mind when we're doing this problem here. So x plus 3, leave a little space, and then the square root of x squared plus 1 plus 2x. And then I'm going to divide every single term now by the highest power in the square root. And then I'm going to rewrite a new limit statement by simplifying everything. Now once again, like these guys right here, you should be already thinking like you got to replace those with the absolute value of x, and the absolute value of x in this problem is going to be negative x because I'm going to negative infinity. So that's going to be x plus 3, and I'm going to divide this by negative x and negative x. All divided by the square root of x squared plus 1 divided by x squared divided by x squared, and then if I continue this, there's a plus 2x divided by, and I need another negative x over here. Okay, let's go ahead and simplify this. This will be the limit as x goes to negative infinity. This expression here is going to be negative 1 plus 3 over negative x divided by the square root of 1 plus 1 over x squared. And this part right here, there's a plus sign and a negative sign. So that's going to be negative 2 because those x's just cancel off. All right, let's go ahead and substitute negative infinity here. So it goes in there, it goes in there. So basically these guys will now go to 0, go to 0. What are you left with on the numerator? Well, you're just left with a negative 1. And on the denominator, you're left with the square root of 1, which is 1. And you're left with minus 2, which is minus 2. Final answer will be negative 1 over negative 1, which is positive 1 as a final answer there. Okay, let's move on to the next problems. Okay, so I like question number 5 right away because I can definitely use method number 2 if I want to. I will go ahead and do the longer way first. The highest power in the square root, in this case, is going to be x squared, so that's going to be x squared there. And because I'm going to positive infinity, I know that the absolute value of x will be replaced with a single x. So let's go ahead and rewrite this problem again as the square root of x squared minus 1 plus 3, leave a little space, divided by 2x. And I will go ahead and divide every single term by root x squared, divide that by root x squared, and divide that by root x squared. All right, and then we need to simplify. So this will be the square root of x squared minus 1, all divided by x squared, all divided by that by x squared, plus 3 over, well, this expression right here, once again, that's the absolute value of x, and in this case, the absolute value of x is going to be positive x, because we're going to positive infinity, so I will go ahead and just put a single x down there. All divided by 2x divided by x. Okay, so let's go ahead and write the next step here. We have another limit statement here. The limit as x goes to positive infinity. Now this part right here is going to be 1. So the square root of 1 minus 1 over x squared plus 3 over x, all divided by, well, those x's here cancel off, and then I have a 2 there. And if I go ahead and plug in infinity now, things should work out very nicely. That and that. So we know that those guys go to 0, those guys go to 0. You're left with the square root of 1 on the numerator, and you're left with 2 on the denominator, so final answer is 1/2. Okay, if you wanted to use method number 2 in this question, you can, because you have constants here, and so basically, sorry, let me just erase all this. That's always the toughest part of making these videos, is erasing content and changing colors. Method number 2. So here's a constant, right? Now constants just, oops. If you have a constants just go to 0. Then ask yourself, inside the square root, what has the higher power of x? Well, it's the x squared term. So on the numerator, the only thing that really survives is the square root of x squared. And on the denominator, well, there's nothing on the denominator to compare things. So the term with the highest power of x is 2x. So you just leave 2x on the bottom. And this is the limit as x goes to infinity. And remember, this guy right here is going to be the absolute value of x. And the absolute value of x in this case will be a single x. It's going super fast here. The x's cancel off and you get 1 over 2. So same answer there. That method might be a little bit quicker because we can actually apply that to this problem here. All right, question number 6. All right, so for question number 6, look at the powers in the square root. So the highest power in the square root is the square root of x to the power 4. So we're going to divide everything by the square root of x to the power 4. So 4x to the 4 plus 3x squared. Leave a little bit of space. x squared minus 4x, and then we're going to divide everything by the square root of x to the 4. All right, now going back to like a grade 9 math class, if you have something like that, that's the same thing as x to the power of 2. So the square root sign and this even power 4 simplifies to just x to the power 2. So let's keep that in mind when we're solving this problem. All right, so that now this will become the limit as x goes to negative infinity, and we need a big square root sign of 4x to the 4 over x to the 4 plus 3x squared over x to the 4, all divided by, well, this is going to be x squared. So I have x squared divided by x squared minus 4x over, and that's also going to be x squared, x squared. Okay, so we need to move on and do one more simplifying step before we substitute x goes to a negative infinity here. These guys cancel off, so you're left with 4 plus 3 over x squared, all divided by, well, that's just 1 minus 4 over x. And you should be confident now that these guys go to 0 when you substitute infinity. So on the numerator you have root 4, on the bottom you have 1, root 4 over 1 is just 2. All right, so a lot of steps there to get the final answer, but it works out. And I will also show you method number 2 for this question as well. Now the problem with method number 2 is it works like 85% of the time in my class, and what you have to do is when you have these limit problems, look at the numerator, and the good thing is that both of these terms are inside the square root sign, so it's a fair comparison. If I have another term out here like x to the power, sorry, I was just saying if I have another term on the outside the square root like x to the power 3, you can't really compare this with this and that because these two terms are inside the square root and this term is not. So you can't compare like the powers. In this case, we don't have that, so we can definitely compare the powers inside the square root. Now, which power is higher, the 4 or the 2? Well, the 4 is higher, so this one can just go to 0. So now I have the limit as x goes to negative infinity. Sorry, this is still method number 2. And on the numerator, I just have 4x to the power 4. Now on the denominator, I mean, I can compare those because they're not within a square root sign, and ask yourself which one has the higher power. Is it x squared or the 4x? Well, it's the x squared that has the higher power or the higher degree. So you can just leave that as x squared on the bottom, and that guy will go to 0. Okay. Now on the numerator here, you can simplify this radical into root 4 times root x to the power of 4 divided by x squared. And I told you in the previous question, this expression right here in green, this is covered in math 10 and 9. That just simplifies to x squared. And you'll notice that you get some nice things canceling off here. Those cancel off, and now you're left with root 4, which is 2, which was the exact same answer that we had before. Okay, I think I'm probably going to stop the video here, and in the next video I will look at more vertical asymptote questions. Alright, so thanks for watching.